we're all here about, the new version of 7.1 and those generators and kind of working through how to use and build those generators. And today, I plan to kind of take you through the new build guide that was just released with the final version of the unit, talk about sort of workarounds and fail safes, dealing with catastrophes. There are some safety nets here if things go wrong or if you're having trouble with your generators. Got some good news about NASCO kits that I want to share as well. And then we'll set aside some time just to, talk about these generators and experiences building them and all that sort of good stuff. So one of the biggest resources or most important or most useful resources when you're looking to build these generators is going to be the new build guide. So just in case you're not aware of where to find that, it's part of the unit challenge resources. So if you're on the main unit page, unit challenge resources, and the build guide here. And that's just a slideshow with a bunch of pictures and tips and tricks showing how to build these. Let's see, I'll start this beginning. All right. So just in case anyone's unfamiliar with, what this is the new fidget spinner generator. There's a lot of things we really like about it compared to the old generators from 7.1. It's a lot more flexible. Students can explore it more, ask different types of questions, see a lot more sort of relevant relationships with fields and energy transformations. Generally works better. The materials are a lot easier to source. But they at least need to be put together. And so that's what we're going to kind of work through right now. Just a little bit of vocabulary that I'll sort of be using throughout the video. We have a fidget spinner, some magnets, and then the real important part of these generators is this copper coil down here. Which is secured with some wrapping wire just to keep it shaped. That coil has two leads or two ends of the wire coming off of it, which is attached to an LED. And, when we're building these, there's kind of four important steps: getting the right materials, building the coils or buying the coils, assembling the generator, and then assembling this neat little falling mass apparatus that's used in lesson 5. So gathering the correct materials, I think even if you get a kit from NASCO, it doesn't hurt to double check your materials. In the beta test, this was a pain point for definitely some teachers. They ordered the wrong kind of wire, built the generators, and then their generators weren't working because they weren't using the right wire. So that's probably the really one of the few must-have, like no substitutions. You have to have magnet wire. The size of that magnet wire should be 36 gauge. That's the size we really recommend. We've tested 34 gauge, which is a little bit bigger. We've also tested 40 gauge, which is a lot smaller. And 36 we felt was a nice balance between the size of the wire was a little bit easier to work with, but still small enough that it worked really well. And so what magnet wire is, so, this is sort of my roll of magnet wire. This is a 4-ounce spool. It's about 3,500 feet of wire, somewhere around there. So a little bit more than a half mile. It should make about 9 coils. And magnet wire is copper wire that's covered in a thin, flexible insulation. And that insulation is really important. And a lot of the sort of details and things I'm going to be talking about today is all about how we can make these coils while we're protecting the insulation on that wire. Another just materials thing that you want to make sure you have is neodymium magnets. If you did the beta test, you might have some round ceramic magnets kicking around, but make sure you have the silver neodymium magnets. From the beta test, we were originally trying to keep, we really wanted to keep costs down as much as we could. And so we originally recommended these cheaper 12 millimeter by 3 millimeter magnets, and they work fine. You can make a working generator with those. But in this newest version, we're now recommending these bigger magnets just because they work a little bit better, and that gives you a little bit of more wiggle room. You don't have to spin the fidget spinner generators quite so fast. Let's see, looks like Chris. So Chris, I think I'm going to be able to get to a lot of these questions in the next couple of minutes, but I'm going to parking lot them for now, and I think we'll get those addressed. So yeah, make sure you get neodymium magnets. If you can get these bigger size magnets, that's what I would go for. But if these smaller ones are the only ones you have, you're okay. Kind of the same thing for fidget spinners. If you can get fidget spinners that have a bearing like this, or like this photo, that makes it a little bit easier to build the falling mass apparatus for lesson 5. But as long as you have something with a hole, you'll be okay. I think even if you have something that doesn't have a hole, you could figure it out. It's just going to take you a little bit more work. And then finally, one of the differences between the beta test version that we had out last year and the newest version has to do with the colors of the LEDs. We were originally using white LEDs just because they're really bright and impressive and it looks like a flashlight. And those work great if that's what you're using and your fidget and your generators, you like that, like by all means keep using it. But the red ones are a lot easier to light. And so that just gives you a little bit more wiggle room too with your builds. So the red LEDs are a lot easier to light. You don't have to spin the fidget spinners quite so fast. So that's something to think about. It's probably good to pick a class color. The different colors need a different amount of energy to get lit, but that really starts to get into some high level electronics sort of phenomenon. The last point here is there are some UV LEDs kicking around on Amazon. Just avoid those because, if they're truly truly a UV LED, you're not going to be able to see those. All right, so when you're building your coils, there are just some required tools. Again, if you're beta testing, we didn't necessarily say all of these things were required, but now we really think you need to have these. There's an arbor. You're going to need it, and you're going to need a drill. The arbors are 3D printed. The files are available here. And completely realize that not everyone has a 3D printer. I printed mine at my local library, so that's something to look into. I'd say talk to your science consultants and people at your ISD or your RESA. I know when I worked in classrooms, I wrote a couple grants to get some 3D printers. I would imagine that might be pretty common, and there's some printer kicking around somewhere. And these aren't super complicated. They don't take a long time to print. So you might be able to have a colleague in a different building print you one. And finally, if that's not an option, there are 3D printing services, both locally and nationally. If you Google 3D prototyping services, there's several different companies that can do this. And the costs aren't astronomical. And there's also often local companies that do 3D printing as well. And you only need this arbor if you're making your coils. If you buy your coils, the arbor isn't a problem. So building the coils. So this, give me one moment. Try to get my materials here without putting everything in my lap. So this is my sort of coil winding setup. It's typically lives in a bench in the basement, but trying to make a slightly more mobile version for this training. So you'll see the little disclaimer there on the slides that the pictures in the guide, in this build guide, some of them are using materials that won't actually build a working generator. It's just what would show up here. Same thing. I'm actually using some garden twine because that's the closest thing that would barely show up on the webcam. Hopefully you can see that. I did have to change my shirt to get a little contrast to give everyone at least a fighting chance. So this is my arbor. One of the things that I like to do kind of right off the bat is on the inside of the arbor, there are some marks just right into the 3D print. And that corresponds to a coil that has 1,000 turns, which is the size of coil that we're shooting for. And just covering those in pen or some Sharpie really makes it a lot easier to see. And the coil also has little cutouts there, so they actually register. It's kind of hard to see, especially on the webcam, but they register right into the arbor, and that becomes important for winding the coil at the end. I like to hold everything together just with a little rubber band. That isn't strictly necessary, but it kind of, I don't know, just saves me some headache. So put that together, just push the rubber band down, and now everything's just held together. It's one less thing to lose track of. And I can put that, oh, actually, I like to put the wire on before I put it in the drill. It's just a little bit easier to handle. So the wire doesn't really matter how you do it, but I like to put it through and then just slide it through one of the holes on the side. Sorry, I'll do it on the side facing you. So right through the edge, give yourself 6 or 8 inches. That'll be the lead. And I like to do the side with this peg first, just because then I can kind of wrap my lead around that. It's not flopping around. And I like to secure everything with tape, just because, again, then nothing's flopping around, right? So put that in my drill. And this next part is actually really important. It's where you can really go wrong. And hopefully you're going to be able to see it. But I want to make sure that my drill and the coil that my wire is coming off of are turning in the same direction. And what that does is that keeps the wire from twisting. If they're turning in different directions, that introduces a twist to the wire, and that twist can cause problems with the insulation, can cause kinks. It causes just headaches coming off the coil, and that can, I think that's a cause a lot of the troubles that people were having with coils. So start slow, and I'm going to just wind this. You can see my drill is turning to the right. My spool is turning to at least my right. And I have my hand here, and all this hand is doing is guiding the coil, guiding the coil onto the wire, just trying to keep it even. These coils do not need to be super tight. The wire is thin enough that you can absolutely apply so much tension that you're stretching the wire and damaging your insulation again. So just guiding with this hand, and I'm not going to do it in the demo because this twine's so big. But once it gets going, you can go, I go full speed on speed 1 of my drill. That's about 540 RPMs. I have done coils on speed 2, which goes a lot faster, but I just don't feel confident that I'm not going to break anything going that fast. So the actual winding itself, I don't feel like it takes that long. So I stick to speed 1. And once I hit my line, I'll stop. So the lines, you can stop once you touch the line or once you cover the line. Either should work. I tend to, if you're going to err on one side or the other, I'd probably err on making your coils a little bit bigger than they need to be. And that'll just give you a little bit of margin and making sure you have a working generator. So now that my coil's done, I like to use a little bit of tape to secure the wire here, just so it's not flopping around, and then cut my lead just using a pair of scissors. And you take the lead, and now you pass it through the other side of the arbor. Ooh. And I might have some trouble with my garden twine here. So, okay, got it through. So I now have one lead going through one side of the arbor, one lead going through the other. And again, I am going to tape this down. It's probably not strictly necessary, but it just kind of helps me stay sane. And so, this is my sort of pretend garden twine coil at this stage. So, I think it's really important that you have your coil or the spool of your wire here on something steady. These coils are sort of a three-handed job. So you want like a vise or a lab stand. This is a little tool that I got when I thought I'd want to be into fly tying that's really useful. There's a picture in here. A chopstick stuck into an apple, I think, would probably work fine. Just, keeping this all sort of stable and steady in respect to one another. Every step of this process, we're trying to minimize the chance of kinks and twists in this wire. So having a stable platform for the drill, stable platform for your wire spool should really help you accomplish that. Okay, now. So I kind of showed you very quickly how the coil is wound. What the coil does is probably a little bit beyond my understanding of electronics. Probably, you can make this as complicated as you want it to, but essentially when the magnets move over this coil, they're causing electrons to move within the coil, and that movement of electrons is electricity. So this is the part of the system that's really converting the kinetic energy in your magnets into electrical energy. And how well that conversion works depends on lots of things: the size of the wire, the length of the wire, the area of the coil, the shape of the coil, if there's anything inside or around the coil. There's whole schools of engineering dedicated to maximizing these coils and their energy transfers. This size and shape is a size and shape that we found through trial and error. We thought it worked the best. So again, for planning purposes, there's about 350 feet of wire in a coil. That's about 9 coils per 4-ounce spool. And in a minute, I'm going to show you how I like to wrap them. The wrap is just there to help keep them their shape. And we like to use a slightly thicker copper wire to do that. You could use, I've seen tape used, I've seen fishing line, yarn would probably even work. Try to stay away from anything that'll be attracted to a magnet, because that could cause some confusion in lesson 3. So things like twist ties from the grocery store, those have a steel wire inside that'll attract a magnet. But other than that, what you wrap it with shouldn't really matter. Some sort of important properties of this, or some of these are important, some of these are just properties. The inside is about 3/4 of an inch. The outside is about 1.25 inches. Like I said, about 350 feet. And we're shooting for 1,000 turns. The number of turns is one of those properties of the coil that are pretty important. I've made coils with about 800 turns that have worked. But again, if you're going to err on one side of that target, I'd make your coils a little bit bigger rather than a little bit smaller. Kind of an easy way to gauge the size of your coil is the coils that I make with a 26 gauge wire wrap is right about 10 grams. That's kind of my target. I found that is a coil that works really nicely. And another maybe slightly more advanced way to test sort of your coil size is to measure its electrical resistance. We'll talk a little bit more about why that might be useful towards the end, but you're shooting for a resistance of right around 160 ohms. That again is a size of coil that I find works really well. And for me to make this using sort of the setup that I just showed you, I can go from a coil sitting on my vise to a wrapped coil ready to go in a generator in 12 minutes. It takes me about another 4 to assemble the generator. So, you know, from raw materials to working generator, it takes me about 16 minutes.
Come on in.
Did you ever find your spinners? Did Eric ever find them?
Oh, he froze. No, because they don't have the spinners, but all of the other stuff, he's saying he didn't get it.
This
So
should be in like a grape box.
I thought it was just a regular box.
No, the
Okay,
regular box is what I gave him later.
He
Chris,
said there
Chris,
was
do,
no.
do you have a question, or did you mean to mute yourself? Sorry, I was just hearing some. Okay, great. Sorry about that, Chris. If you do have anything, you know, feel free to jump in. So yeah, at least for your first couple, I'd plan on that taking a little bit longer, but you know, once you hit your groove, around 15 minutes a generator with making coils. If you buy your coils, talking 4 or 5 minutes a generator. And again, this winding part, I think, is where, if people who had trouble in the beta test, this is, I think, where a lot of people went wrong with kinks due to twisting, and also getting cracks in your insulation due to too much tension, or I think a couple people had issues with wrapping. They're either doing too tight or just with too much friction, and that causes damaged insulation. And when your insulation gets damaged, that can cause short circuits. And in this context, a short circuit, so instead of those electrons moving through like all 1,000 turns, they might be able to take a shortcut and say, just travel through 300. And that's going to be a much shorter path through the coil. And it's not going to be as an efficient of an energy transfer, and you're going to run into trouble. You know, you want to be using all 1,000 turns. So really at sort of every stage of this, you know, be thinking about how can I protect that little bit of insulation on the wire. So yeah, tips to succeed. Like I said, wind on a table, check your winding direction, guide the wire, don't tension it. And I'm going to just kind of skip through these because I think I covered it in the hands-on. This picture here, you can see, you know, chopstick and an apple, vise, lab stand, but really just something that'll hold that spool for you so you don't need to hold it. I like to keep the spool at about a 45-degree angle because I'm not the best spatial reasoner. And so having it at a 45 makes it easier for me to tell which way it's turning. And then it also is less likely to fall off. You know, it's not going to, if it was perfectly horizontal, it could just like work its way off and fall off and then be a headache. So 45 degrees works really well for me. Okay, covered that. Talked about securing those leads. Okay, wrapping the coil. I made myself a little bit of swap. I'm using wire that's much thicker than what you probably want to use. So you're going to see me struggle a little bit more than you probably will. But I just wanted to make sure that you'd actually be able to see it in my webcam. So yeah, here's the arbor, you know, where we left off. We got my leads secured on both ends. I have the wrap started. But the reason that you want to make sure that the arbor is registered into each other is these little slots will help you with winding. So I'm coming out of the outside hole here. I'll go in the inside, and that sort of pokes it through the next slot that I need to work through. So you just do that in and out, sort of all the way around. and just keeping this snug. Again, like you don't need to go crazy here. And just in and out, working your way around. I personally like to wind the entire coil on the arbor. Other people who've made these like to just do a couple wraps and then take it off. That they feel like it works a little bit better for them, but I just like how secure it is on the arbor. I feel like I make prettier coils and with fewer flyaways, and those flyaways are just things that might get caught by a student. The reason I'm struggling here right now is because I'm using this giant wire and garden twine. It doesn't quite want to fit through the holes. There we go. So, all right. So once I have it all the way wrapped, I can untape my leads, take the top off, take my rubber band off. The top will slide out, and you can now kind of see that wire is just wrapped around my coil. Now, when you're doing this with, actual copper wire, it might not fall off like this twine wants to do. And so that is where I like to just use a popsicle stick or a pen cap, something that I can just work in from behind and just kind of stick it through and get it started. And you can just kind of work it off. And, now you have your wrapped coil. Usually, when you do it as well, you'll probably have some extra wire. I usually just kind of tuck it around, maybe trim it off. And what we're going for is a coil that has all the loops sort of secured by the wrapping. And if you don't get all of them, it's not the end of the world. It's just really trying to cut down on things that can get caught by students. And it's kind of hard to communicate, but your coil, you should still be able to like squish it. And I can't really think of a better word to describe sort of the tension of the coil, but it's not under so much tension that it's like a hard, solid object. We just kept everything, firm, but not trying to tension anything, so that this wire, you can see I can still move this coil, I can still shape the coil. It's not super tight. And avoiding going so tight, you're not going to stretch your wire, you're going to protect that insulation. So yeah, the same thing with the wire. You want to keep it snug, but you don't want to really crank down on it or let it slide over the wire a lot where it might be rubbing off that insulation. Really, every step of this process, be thinking about how can I protect this wire's insulation. So now, at this point, you should have hopefully a working coil. But before you go out and make, an entire class set, make your first one, maybe even make your first couple and test it, just so you know that you have a good working system, before you dive into mass production mode, just in case if you are doing something wrong, you want to catch it on your first one and not your 10th. And so, the easy way to test that would just be to quickly, hook it up to an LED, give it a spin, or we'll talk a little bit later again about using a multimeter to measure the resistance. And, if you remember, we're shooting for about 160 ohms. That coil in the camera is probably a little bit small, 144, but it works fine. So keep it sort of in that neighborhood. If I was seeing it around like 100 ohms or maybe 120, I'd start to worry a little bit more, maybe do an LED test. But the bigger the coil, the more resistance it'll have. So if you're, 160, 170, 180, you're probably okay. Now, if you are going to buy coils, you can skip this whole coil winding business and go straight to assembling the generators. And to assemble the generator, what you want to do is you need to strip some of the insulation off the ends of your leads. So that'll let you make an electrical connection between the coil, where those electrons start moving, and the LED, where they're going to do some work. And the best way that we found to do this with this wire is using a lighter, which sort of mimics soldering. And hopefully this is going to come across the webcam, but just a quick wave, and maybe you notice that little flash. That's all it needs. This is now stripped wire. I just wipe the gunk off with my fingers. If you get too overzealous, you can burn the wire. So I don't know if you can see it, but in person, it's very clear that that wire was melting and burning. So that's something you want to avoid. Just a quick wave. If you have the skills and tools to solder this connection, by all means solder it. That's probably the best way. But this wire wrapping can work just fine, and then you don't need any special tools. The sanding the insulation off with this 36 gauge wire, I'm not confident that you'd be able to get a good enough connection. I'd worry about breaking the wire or not getting all of it off. This, a quick wave through a lighter, a quick little flash, just like that, you're good to go. So that's what I would really, really recommend. The other, sort of the next step, I kind of have my model wired here. So, this little end has the insulation stripped off. And now we need to attach the wire to our makeshift LED here. And probably the most intuitive way would be to take the wire and wrap maybe the most intuitive, and also probably the easiest way, is to have the LED here and wrap the wire around like this. But there's two things that you want to be careful about that. The first is that you're going to introduce a bunch of twists down below in your lead when you do that, and twists are something we really want to avoid. And also, you're going to have a little stray end at the top of your twist, and you're going to have another little stray end at the top of your twist over here. And if those stray ends touch, you can get a short that'll cut your LED out of the circuit, and that can cause problems. So instead, what I really recommend that you do is take your lead, fold it like this, and then then you can hold your strip end and wrap it around the LED and the lead, and connect it that way, which you can see in these photos here. And that helps eliminate the number of cuts down on the introducing twists and keeps those stripped ends further apart from each other. You'll also notice on these LEDs, I like to bend the legs out a little bit just so I have a little bit more room to work with and I can get my fingers in there. So once you have your LED on, you're in your home stretch. The next step is just to kind of secure the parts down. We're really kind of just liking tape to do this. It seems to work pretty well. And it's pretty easy to do. So tape your LED down, tape the coil down. If you can see in this picture here, these leads, I'll put some tape over that just so that there's nothing sticking out that can get caught on a fidget spinner, get caught by a student. And like a wider moving tape. Yeah, packing tape works. I've used packing tape. Scotch tape works fine. With packing tape, the only thing you want to be a little bit careful of, and this is really easy to avoid, but because it's thicker, if you get like a crease in it or a bump, that can stick up enough where it starts to hit the fidget spinner and slow it down. So if you're using packing tape, which looks a lot nicer and it's heavier duty, just make sure that when you press it down, you press it in like a nice flat plane, if that makes sense. So we also really recommend adding a handle, and that handle can be as simple as just a bottle cap. I think that the bottle caps work really nice. And to attach those, you just want to rough up both the cap and your fidget spinner before you try to glue it. Otherwise, both surfaces can be so smooth that they don't adhere well. So that could be a little bit of sanding, a nail file, brick wall, just anything to give those surfaces a little bit of texture for the glue to bite on. We also, in the beta test, we had a 3D printed handle, and that could work, but you need to really be into 3D printing and know what you're about with 3D printing for that to work. Just because every 3D printer is a little bit different or can print a little bit different, and those bearings are a very specific size. So you can see in that picture there, my print was just a little bit too big, so it didn't fit really well. And you can tell the middle there actually ended up breaking off a little bit. So I would just save myself the headache, glue on a bottle cap, and now you're good to go. And then the last part here is this falling mass apparatus that's used in lesson 5. And all that is you're going to want to be able to wrap some string around the fidget spinner, and then there'll be a mass on one end of the string. Students can drop the mass, and as the mass falls, it turns the spinner. The reason we like fidget spinners with the bearings for counterweights is the bearings are a really consistent size all the time. And so, whatever we recommend to fit in there will pretty much always fit. And one of the easiest things that's probably in your desk right now is a Bic round stick pen. That is a really nice friction fit in the bearings. If you get a kit from NASCO, I think they're going to include drywall anchors, which also work great. 6mm drywall anchors are a little tough to find if you're sourcing your own stuff. 5/16 should work okay. But I've always used a round stick pen, and I've been happy with that. So if you're having trouble with your generators, a couple sort of easy places to start looking is checking your connections. I shoot for at least 5 wraps around my LED. If I can get more, that's better. And also just double check that you're not sorry, I'm pointing with my fingers instead of my mouse. Double check those ends of your leads too. Make sure that they're not touching and causing a short. The LEDs should generally be good, especially if they're fresh out of the box. It's probably technically possible to cause problems with this where I don't know of any issues of like burning LEDs out. I haven't had it happen. I imagine it's technically possible, so swapping out an LED could be something to try. Where I have run into an issue with an LED is I was using LEDs from like 5 years ago that were just sitting in my desk drawer, and the silver, I don't know, legs of them had corroded a little bit, and I wasn't getting a great connection until I cleaned that corrosion off. So I just scratched at it with a little bit of sandpaper, and the LEDs worked fine. For testing the coils, if you have even just a cheapo, this was like I think it was like $15-20 from like Harbor Freight. Multimeter can tell you a fair amount by measuring the resistance, and that's telling you, you know, if that you have continuity through the coil. You know, your wire's not broken anywhere, and it can really give you a warning about any shorts. So to do this, what I like to do is I put my coil on a sheet of paper, just so it's insulated from whatever I'm working on. You strip the ends of your leads, and then you can hold kind of the multimeter down on those leads and get a reading. It's a little finicky, but it does work. And that can let you know if you're having a short. If you're just trying to use an LED to test, you know, you don't really know if your wire's broken or if it's shorted out. Whereas this could give you a clue as to what went wrong in the building process of the coil. I'm a little pressed for time here, so, you know, if you want to learn a little bit more about using a multimeter, there's stuff in here about getting it set up. And very quickly, just want to talk a little bit about kind of the stakes of building these generators. So the unit, I would say, is excuse me, better in just about every way with working generators. That said, plenty of people in the beta test just used the fidget spinners and the magnets and the videos. They didn't mess around with working generators, and they all reported that their kids were still engaged. They still, you know, hit all the learning marks that they wanted to hit. It worked fine for them. The generators themselves are mainly used in lesson 2. And so that's the one lesson where you really wanted a generator of some sort. You could probably get away with V1 generators if you had those rolling around. But again, we really think these new versions, once you get them working, are just so much better than the first versions. The rest of the lessons, you really just need some neodymium magnets and the fidget spinners. At least, yeah, especially lesson 3, you want some moving magnets. There are videos there. It looks like Chris just released the fidget spinners. You might not get them in time. Yeah, if you're waiting on fidget spinners, there are videos of everything that you can use. But if you could get your hands on even a fidget spinner to do as a demo, I think that would be really helpful. And so, yeah, I mentioned that you can probably reuse V1 generators in lesson 2 if you really had to. But I would go for the fidget spinners. And kind of like the biggest thing that I hope you walk away with this from is, if you run into issues, if you're having a headache, if you feel like you're just annoyed or you have a struggle or whatever, do not hesitate to use the helpline right here on the main page. That'll send an email right to the team. We try really hard to respond the next business day to anything. And, we're more than happy to help you troubleshoot, tips, tricks, whatever you need to get going. To help you with your build. So the NASCO kits, so this is brand new news. We're going back and forth with NASCO for a really long time, trying to finalize these kits, trying to figure out a way to provide pre-wound coils so that that was at least an option. And we finally figured out a way to do that. The kit from NASCO will include pre-made coils. I don't think it's live on our website yet. Kind of the back end of NASCO ordering, I guess, is complicated. So it takes a little bit of time for them to put the ordering forms together. But that's coming. If you really wanted, you could get in touch with them directly at enasco.com/mystar. I believe there's a link there to email them and ask them about the pre-made coils. I do not know the final price on that, but the coils are pricey. There's a fair amount of labor that goes into them, and we looked at lots of different ways to try to keep the price as low as we could, but we really wanted to make sure that there was an option for pre-made coils out there. Kind of the build versus buy breakdown. If you're building these, you're going to save a lot of money. That this 4-ounce roll is floated around between $10 and $11 over the past year, or 2 years since we've been working on this. And that's enough for 9 generators. I think that's, real cheap. And, if you build them, you'll have the capacity to fix them. If something should somehow go wrong, all the data coming back to us is that these have been pretty robust. If there's a problem anywhere, it seems to be in the fidget spinners of them, getting dropped or whacked or thrown. But the coils themselves seem like they've been holding up really well. But, if your problem child takes a pair of scissors to a coil, if you have the skills and know how to build a coil, you'll be okay. The big drawback is the time, at least 2 hours to build a class set. But, that is a one-time time investment. And then the other big drawback is just bandwidth, right? Like, you guys are busy. It's one more thing. Like, I hear you. Buying, it's going to be really easy. One of the things that was really important to us is that NASCO tests every coil that they make, so that we know that they're sending working coils, and that's something that they have affirmed to us. So any coil that goes in a kit should be a working coil, and that's kind of one less degree of freedom if you're trying to troubleshoot a generator. Excuse me. But it is going to be a cost. Like I said, I don't know the exact cost, but I believe it's north of $20 a coil, which is a fair amount. The one good thing about the new kits is that everything is non-consumable, so it's should be essentially a one-time buy. There might be some things like strings or some ceramic magnets that kind of slowly over time break down. Excuse me, but there isn't big cost recurring year after year. The cost, especially from the kits, is a one-time thing.